So earlier we said that the vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k, where h and k are the coordinates of the vertices. So we're going to use what we learned about how to find a vertex and the transformation described by h combined with what we learned about a and k to describe and graph a given function such as this one. We have g of x is equal to 1/2 times the quantity x minus 4 squared. We're going to compare the graph to the graph of the parent function, which is f of x is equal to ax squared. So first let's take a look at the given function. And let's identify the given values. So we know that um, 1/2 is actually the value of a, right? Highlighter on this one. Okay, so we know that 1/2 is the value of a, while 4 is the value of h. So there is no constant added after the square sign or after the quadratic term. So that means we only have two values here. A equals 1/2 and h is equal to 4. So remember, we switch this number to its opposite, so x minus h. So if it is minus 4, then the h value is positive 4. And since we know that k is the constant added after the quadratic term and there's none, so we say k is equal to 0. Alright, so how do these constants affect or transform the graph described by f of x is equal to x squared, which is the parent function? So we know that if the value of a is a fraction smaller than 1 or between 0 and 1, it causes a vertical shrink, right, by a power of 1/2 or by a factor of 1/2. Then h causes the graph to horizontally translate. So this causes the parent function to transform in the following manner: horizontal translation 4 units. Since it's minus 4, you go to the opposite direction. So 4 units to the right. While k is supposed to give the vertical translation. So since k is equal to 0, it doesn't affect the parent function. But we know that the vertex here is given by 4, 0. And that's helpful when graphing because we know that a parabola is symmetric with respect to the origin. So this is 4, 0, right? And we have our axis of symmetry here. I gotta do this slowly. Well, anyway, you can make a better version of this on your paper. There you go. So that is the axis of symmetry. So all I need to do now is, find other points in the parabola. Now, what point should I look for? Should I look for a point somewhere here on the y-axis? Should I look for a point here? Well, it doesn't matter, but I would suggest that you use, the most convenient ordered pairs or x values to use. I normally use the number immediately to the left or to the right. Why? Because keeping the numbers close to the vertex will minimize this value, so I don't have to deal with squaring a big value. Okay, so let's try. I'm gonna get 2 points. So let me write over here. So find 2 points. Okay, so I'm gonna try the number here, which is 5. Okay, let's try 5. So I'm gonna substitute it here. 5 minus 4 is 1. 1 squared is 1. 1 times 1/2 is 0.5. So that means when x is 5, I get 0.5. So when x is 5, y is 0.5. So it's right there. It has to be midway. It's hard to kind of be exact when you're writing on this slate, but it's better than typing. Okay, so now let's find another point. If I use 5 on the right hand side, its partner on the left hand side is 3. So let's find the partner of 3. Let me erase this one now. Okay, so let's find the value of y when x is 3. So 3 minus 4 is -1. -1 squared is 1. 1 times 1/2 is again 0.5. So that means this will also be 0.5. So when x is 3, here the y value is 0.5. So a good estimate or sketch of the graph will be this one. We are not 100% sure about where the graph will cross the y-axis. Okay, but there is a way to find that. So if you want where your graph crosses the y-axis, you're pretty much finding the y-intercept. So if you want to find the y-intercept, so you would have a better shape of the graph. Okay, so let's try that. We're going to substitute when x is 0. So let's take this out. And now let's substitute 0 instead. Okay. Sorry for the ding sound. It makes a sound every time I have to toggle between an eraser and a pen. Okay, so when x is 0, 0 minus 4 is -4. -4 squared is 16. 16 divided by 2 is 8. So that means when x is 0, y is 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's where your parabola will cross the y-axis. And on the other side, just use reflection. Okay, so if you have 0, 8 here, that's 4 spaces away from the axis of symmetry. 1, 2, 3, 4. So count in the opposite direction. 1, 2, 3, 4. Alright, and that will give you a better shape of your parabola. So you can extend it that way. Anyway, so just try to fix that on your paper. It's kind of hard to be writing on this stage. I'm not used to it yet. There you go. So that's not a very nice parabola, but it will do for now. Okay, so let me summarize. In this slide, we learned how to do 2 things. How to describe the graph even before we graph it. And how did we do that? We analyzed the constants that are present in the function. Next, we were able to draw not a very nice parabola, but we were able to sketch the graph. And how did we do that? We started by finding the vertex. Once we had the vertex, we found 2 points. Where did these 2 numbers come from? They were the numbers immediately to the right and to the left of the vertex. Where did the y-intercept come from? We got the y-intercept when we substituted 0 for x. Now, do all parabolas have y-intercepts? Be smart when you're using this. Sometimes, the parabola is farther to the right and it will cross your y-axis at a very high value. So if it's not practical to find the y-intercept, you could just skip it. Okay, so based on the graph, you can describe its key features again, like the concavity, where is it increasing, where is it decreasing. So I'm going to leave those details for you to practice on, and there will be exercises later on how to do that. Okay, another example. So let's go straight to graphing, right? The value of v, or the coordinates of the vertex. Remember, start from here, do the opposite, so -2. Then go to the value of k, keep the sign, so 3. So the vertex is at -2, 1, 2, 3. There you go. Okay, we're expecting a parabola that is opening, we're expecting a parabola that is opening downward. Why? Because a is negative. So a is -2. That means it's concave down, and it has a vertical stretch by a factor of 2. Then h is -2, so that means horizontal translation by, well, that's 2 to the right. And you have a value of k now, unlike in the first example. So k is 3. So that means it's a vertical translation 3 up. Okay, so now let's find the other point. This is our vertex. Let's use the point immediately, before and after. So let's use -1. Let's plug in -1 in here. So -1 plus 2 is 1. 1 squared is 1. 1 times -2 is -2. -2 plus 3 is 1. So when x is -1, your y is 1. When x is -1, you go to 1. You can find its partner on the other side by using symmetry, or you can also plug that in. So let's try, the number here is -3. So when x is -3, so -3 plus 2 is -1. -1 squared is 1. 1 times -2 is -2. Plus 3 is also 1. There you go. So the other point goes right there. Okay. Let's find the y-intercept. I think here it's practical to find it. The y-intercept is when x is 0. So 0 that out. 2 squared is 4. 4 times -2 is -8. -8 plus 3 is -5. So when x is 0, y is -5. So 0, 1, 2, 3, 4, there we go. And by symmetry, let's find its partner on the other side. And with those information, I think we can sketch a parabola. There you go. Alright, so I hope those examples helped you in understanding how to describe the graph compared to the parent function by using its transformations, and how to graph this specific type of quadratic function, which is called the vertex one. So what you're going to do now is go back to your folder, and you will do the vertex form exercises. And then after, there are 2 worksheets that you have to do by hand and upload a picture for grading. Happy graphing!